This question is about redox, and we're supposed to balance the equation to find how many water molecules are produced when 5 ethane dioic acid molecules are oxidized by QP11 in dilute sulfuric acid. Now, the first thing I will do is I will write the overall equation based on this statement, because this statement tells us the products of the redox reaction. Okay, so I'm going to write it here, ethane dioic acid, CO2H, CO2H. Right, it can be oxidized by KMnO4 in sulfuric acid, okay, to produce carbon dioxide, water, potassium sulfate, K2SO4, and manganese 2 sulfate, MnSO4. Okay, now there's another half equation given here. I know that 1 ethane dioic acid will be oxidized to 2 carbon dioxide. So let me just put 2 in front of CO2 so that I know that they come as a package. Okay, 1 ethane dioic acid molecule will be oxidized to 2 CO2. Right? So later, if I multiply this ethane dioic acid by a number, I have to multiply these 2 by that number also. Okay? Right, now if we look at this half equation, I know that oxidation of ethane dioic acid will lose 2 electrons. So meaning whatever oxidation number of this carbon in ethane dioic acid is will become plus 2 in CO2. Okay? Because it loses 2 electrons in this oxidation, in this redox. Okay? Right, so the change in oxidation number of carbon in this redox reaction will be increased by 2. Why? Because we are given here loses 2 electrons, so increased by 2. Now, the oxidation number of manganese in KMnO4 is plus 7. That's why it is always called potassium manganate 7, right? And then here we are given manganese 2 sulfate. So the oxidation number of manganese in manganese sulfate is plus 2. So can you see now the change in oxidation number of manganese in reactant to product will be plus 7 to plus 2. So reduced by 5. To balance the equation for a redox reaction, we need to make sure that this magnitude and this magnitude can be the same. Multiply by a common factor and then they become the same. So I want this to be multiplied by 2 and this by 5 because I'll get 10 and here 10. Okay, we can ignore the sign because we just want to get same magnitude. Now, minus 10 plus 10 means, okay, 1 donated 10 electrons, the other one accepted 10 electrons. So in redox, to balance the equation is like this, okay, the number of electrons transfer donated and accepted must be the same. So if I multiply this by 5, okay, that means I need to put, there's actually a 1 in front here, but we don't always show the 1, right? So 1 multiplied by 5, so this is 5. Now, remember I said if this is multiplied by a number, this 2 must be multiplied by that same number. So here become 10. 2 multiplied by 5, 10. Okay, now we'll do the same for the manganese containing species. So this multiply by 2 here. So let me put a 2 in front of KMnO4 and then also in front of manganese 2 sulfate. Right, now we have balanced the electrons. Now let's balance the other species in the same equation. Okay, Now here, I'm sure the number of carbon atoms are balanced on both sides, but just double check, just in case we have 2 here multiplied by 5, 10 carbon, right hand side 10 carbon. So let me put a tick on top of carbon to make sure that, okay, I remember that they are balanced. Now oxygen, 2 oxygen plus 2, 4 oxygen multiplied by 5, 20 oxygen, and times 2, 20 oxygen. Okay, number of oxygen balance. Okay, now I've H here, 2 hydrogen atoms multiplied by 5, okay, 10 hydrogen atoms. Not balanced yet from ethane dioic acid molecules. Let's look at potassium. I have 2 potassium here. Right hand side 2 potassium. Okay, balanced. And I have 2 manganese. Right hand side 2 manganese. Okay, again balanced. Now this O oxygen from KNO4, okay, not balanced yet. Let me just put it on top of this so that I know that I still need to put it somewhere. So 2 times 4, 8 oxygen. Okay, now let's look at H2SO4. How many H2SO4 I need? Okay, based on right hand side, I have 1 sulfate, okay, plus 2 sulfate, 3 sulfate, and this sulfate ions must be from only sulfuric acid. So 3. I need 3 sulfuric acid molecules so that the number of sulfate ions are balanced. Okay, now 6 more hydrogen here from the H2SO4. Now can you see that this altogether 16 hydrogen and 8 oxygen must only go to H2O. So how many H2O molecules will give you, okay, 16 hydrogen atoms and 8 oxygen atoms? So 8, right? Okay, 8 times 2, 16. 16. 10 plus 6, 16, right? 8 times 1, 8 oxygen, so 8 oxygen. Right, now let's look at the question again. How many water molecules are produced when 5 ethane dioic acid molecules are oxidized by KMnO4 in dilute sulfuric acid? So here we have 5 ethane dioic acid molecules. So how many water molecules are being produced? 8. So the answer to this question is 8. B.